function compared to an exponential function. So if we look at 2 to the power x, y equals 2 to the x. Okay, if we look at y equals 2 to the x, okay guys, quiet. So if we look at y equals 2 to the x and we want to get the y that goes with this, we actually just have to do the math to it. So this would be 2 to the negative 3. That would be how I would get my y. 2 to the negative 3. 2 to the 3 is 8. 2 to the negative 3 is 1 over 8. Because remember, you can just drop it to the bottom. This would be 2 to the negative 2. 2 to the 2 is 4. 2 to the negative 2 is a quarter. This would be 2 to the negative 1, which is a half. This would be 2 to the power of 0. What's anything to the power of 0? 1. This would be 2 to the 1, which is 2. 2 to the 2, which is 4. 2 to the 3, which is 8. 2 to the 4, which is 16. What's its inverse? Remember what the definition of inverse? Yeah, swap the x and the y's. That's it. So do you remember about inverses? Actually, the great thing about inverses, we don't ever have to find the inverse equation unless asked. Unless someone says, what is the inverse equation? We do not have to find it. Why? Because let's go over these things. Original. Say this is the original graph. I know the original graph's points are x, y. We agree? The inverse graph's points are what? Yx. So their mapping would be x, y, actually becomes yx, right? That would be the mapping for it. Okay, let's think about it. Let's go back to inverses in our heads. Our domain of our original is what of the inverse? Our domain of our original, yeah, is the range. So if I find the domain of the original, I have the range of the inverse, because your x just become y, correct? Yeah. Yeah. So did I have to find the actual inverse to get the range? No, I just need to find the domain of the original, correct? Yes. So the range of the original would be the what? Of the inverse? The domain. The domain. Wow. Winning. Who's this smart guy? Right? Right? The x-intercept would be the?
Y-intercept.
Because the 0 for the y would now become the 0 for the s. Thank you. The y-intercept would be the?
X-intercept.
I feel like I need to go faster because they told me to slow down. No, faster.
Oh, we're supposed to write them.
If you want to, it's your note. And then we can talk about other things. Let's say, for exponentials, what kind of asymptote do we have?
Horizontal.
We have a horizontal asymptote. Horizontal asymptotes are what equals?
Y equals.
Y equals. Why are you guys even answering? It's literally just, Colton's got all the answers. They're y equals a number. Of an exponential, they're actually y equals the what translation? Do you remember? Vertical translation.
I'm sorry, I was a little slow.
Because they're normally at y equals 0, correct? So our asymptote is, for our exponentials is our vertical translation. Boom, boom. Moves it up or down. Okay? Now, what would that be on the inverse graph? Yes, please.
Horizontal.
Horizontal would become the?
Become the vertical.
Vertical.
I'm sure.
And instead of it being a y equals, it would be a? Yep. X equals number. And instead of it being based off of the vertical translation, it's going to be based off of the?
Horizontal.
Yes. You've just learned logs.
Hey, I wrote all of that down, but I don't think I retained any of it.
Why would you write it down? You can just remember it. Like.
Okay. He's riding on a high right now. That's a math high. Okay. So what we need to know is, did I even need to find out what the inverse equation is?
No.
No. So honestly, the only time you have to find the inverse equation is if it says determine the inverse of blah. That's it. Other than that, you can answer every single question on it from the original. Because the original's domain becomes the inverse's range. The original's range becomes the inverse's domain because x and y split. That's all that happens. The x-intercept becomes the y-intercept. The y-intercept becomes the x-intercept. The horizontal asymptote becomes the vertical asymptote. Literally, it just all flips, correct? So we don't need any actual information about the inverse if we have the original. So some people try and find the inverse all the time. The equation, you don't have to. You can just use your inverse, your original. But let's draw the inverse. So if I have y equals 2 to the x, its inverse would, instead of negative 3 and 1/8, is going to be 1/8 and negative 3. Instead of negative 2 and a quarter, it's going to be a quarter and negative 2. A half and negative 1. 1, 0. So do you see? This here, my x is 0, my y is 1. So this is a y-intercept. It now became a x-intercept. Do you see? The x and y swapped. This becomes 2, 1, 4, 2, 8, 3, 16, 4. The coordinates just switch. So we're going to sketch these on the same axes. So we have negative 3 and 1/8. I'm going to do the exponential in blue. So negative 3 and 1/8 is here. Now I know it's y equals 2 to the x, correct? What's my vertical translation, sorry, on this one? Y equals 2 to the x. What's my vertical translation?
There is none.
There isn't one. It's a plus 0, isn't it? So what's my horizontal asymptote at? Y equals 0. Can I write HA on the test? No. The only short form you can use is LS and RS. Don't try anything else. It doesn't work. It's bad for you. Okay. So we have y equals 0. So I know I'm going to actually have a dashed line on the x-axis because that's the line y equals 0. I know I have negative 3 and 1/8. I know I have negative 2 and a quarter. I know I have negative 1 and a half. I have 0, 1. I have 1, 2. I have 2, 4. I have 3, 8. And I've ran out of room. So this is going to run along here. Pretend that's really close to the x-axis. It's just getting worse. And then it cuts through your points. And it goes up. What do we know about the inverse? What does it reflect on? Do you remember? Yeah. Jeez. Did you just, like, did you pay lots of attention during the inverse lesson way back then?
2018.
Yes.
The line is like.
The line y equals x.
Okay.
Just flaunting, it's fine.
The line equals.
The line y equals x. So, the line y equals x is literally when y equals x. So it's 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2. Now remember, reflections, whatever you reflect on is where your invariant points are going to be, correct? Because if you reflect on that, that's like the mirror. And I always explain this and I say, did you ever do this as a kid? And everyone looks at me foolish. But I really thought people did. So as a kid, have you never taken your toothbrush and put it against the mirror to see it reflect?
What?
Okay, good to know no one still does that. That's good. I did. I assumed all children did. But if you put your, I was testing out reflections at the time again. If you put your toothbrush up to the mirror, it'll reflect in the mirror, correct? But the only part that won't reflect is actually the piece against the mirror, correct? It stays the same, which is just an invariant point. So if all you have is a reflection, if you have other things like stretches, reflections, translations, it throws it all out the window. But if all you have is a reflection on the x-axis, let's say that's all it is, then the x-axis is where all the invariant points are going to be. Because that's the part that's not going to change, just like your toothbrush against the mirror. That's the part that's not going to change. Everything else will flip, right? So if all you have is a reflection in the x-axis, the only place that stays the same is the x-axis. If all you have is a reflection in the y-axis, the only thing that stays the same is everything on the y-axis, correct? Catch with those is often you have stretches, reflections, translations with it. It makes it more complicated, correct? But inverses, we only have one reflection. That's it. It's a reflection in the identity line, which is the line y equals x. So 0, 0, 1, 1, 2, 2. And those are going to remain invariant because if I flip 0, 0, 1, 1, 2, 2, what happens? They stay 0, 0, 1, 1, 2, 2, right? Like if I flip the x's and y's, that's why they remain invariant. Now, everyone notices those ones, but everyone forgets about all the decimals that fall in between these. So I'm just drawing this, pretend it's straight for my welfare. This is y equals x, this is the identity line. And it's where all your invariant points are going to be. So not only is it all these points, but in between these points, this is where people get bad marks on the diploma. It's not just 0, 0, 1, 1, 2, 2. It's also 0.5, 0.5, 0.75, 0.75, right? Like there's a whole lot of decimals that are following along there. Correct? So currently, I don't have to draw the inverse right now. I can just draw the original, correct? How many points are there invariant between the inverse and the original? None. Because how many times does this cross that line? It doesn't. It doesn't. Settle. Right? So I, once again, do not have to find the inverse equation. Did I have to find the inverse equation to determine how many invariant points there are?
No.
Nada. So when do I have to find the inverse equation?
Never.
When it says determine the inverse of this equation. That's it. Other than that, you really don't have to. Because I don't even know what the inverse is of this equation, but I can draw it. Let's go draw it. So instead of drawing 1/8 and -3, it's going to be -3 and 1/8. I'm going to use a different color. Instead of it being at -2 1/4, it's going to be at 1/4 and a -2. Instead of being at -1 1/2, it's going to be at 1/2 and -1. 0, 1, which is a y-intercept, becomes 1, 0, which is an x-intercept. And then 1, 2 becomes 2, 1. 3, 4 becomes 4, 3. And then 4, 8 becomes 3, 8 becomes 8, 3. 8, 3, that's a lie. Is it 3? This is a 2. Oh no. Extremely large eraser is not going to work well in this situation. What else? This is 2, 4, so it's going to be 4, 2. No, it switched. Why did it switch to red? And then this is 3, 8, so it's going to be 8, 3. So it's running along here. And it's coming along there. And then, instead of having a horizontal asymptote at y equals 0, I now have vertical asymptote at what? And no invariant points, right? It didn't cross it. Let's go, this has nothing to do with logs and exponentials. Let's say I draw this. How can I figure out how many invariant points there are if there's just a reflection in the x-axis? Yeah.
How many times it crosses the x-axis?
That's it. 1, 2, 3. Boom. Done. What if I say there's a reflection in the y-axis? Yeah.
How many times it crosses the x?
Which is 1. Now what if I say inverse? If it reflects in the line y equals x, or I say it reflects in the identity line, or I say it's an inverse graph, well, you would actually need the scale, which I did not give. But let's pretend that this is the line y equals x. I would just sketch it. It's totally straight. Be quiet. Don't judge me. How many times did it cross? Yeah. Yeah. You're not answering your questions. Chillax. How many times did it cross? Not you. You're fine. You wanted to go to the bathroom. So yeah, go. You go. I believe in you. Okay. 2. Good luck. All right. Okay. What's the domain of the blue one? Which is the exponential. X and M of the reals. So, of y equals 2 to the x, it's somewhere on here. It should be on your paper. Yours is on your paper. Like if you look, you have it on paper. Mine didn't print. So thank you, paper. So you have domain. We're going to do, it should have 2 boxes. I'm sorry that it does not. So we're going to have like this. Draw yourself another line below. Or don't. Do what you want. I don't even care. Okay. So the domain, this is going to be of y equals 2 to the x, and this is going to be the inverse. So we're going to do the 2 to the x ones first. What's the domain of the 2 to the x? You guys said XER, correct? What's the range of the exponential? What's the range of the blue one? Yeah.
That's greater than or equal to 0.
Y is greater than or equal to 0?
No, just greater than.
Yeah.
Just greater than, not equal.
Because?
Never touches.
Exactly.
Zero is bad. It's allergic to
Because 0 is bad. It's allergic to it. It's an electric fence and you're going to get shocked. Yeah? Okay. The asymptote.
0.
What 0?
A horizontal.
What 0?
Y equals 0.
Yeah. So I can go h of a because these are my notes. But I can't do HA on my test. Horizontal asymptote, y equals 0. And then intercepts. There's just a y-intercept at 0, 1. You're correct. Now the inverse, I don't even need to look at it. I can if I want to, but I'm a rebel without a cause, so I'm not going to look at it. I don't need it. I don't know why I'm doing this so backwards. I'm going to use black. I was going to go with the colors, but then I would have done blue for green and green for blue, which is stupid. Okay. Domain would be what?
It's such that x is greater than or equal.
Yeah, so these y's are just going to become x's now, right? So the range is going to become the domain. X such that x is greater than 0, XER. And the domain, XER, is going to become YER, so that's going to become my range, which makes sense. This baby's going on for life. Instead of it being a horizontal asymptote, it's going to be a vertical asymptote because it's not going to be at y equals 0, it's going to be at...
X equals 0.
He's just so happy. Someone could take away all your money and you would not ruin his day today. Okay, the x-intercept, instead of it being at 0, 1, it's going to be at 1, 0. Okay, then we're going to flip over.
That's
Dude, I just handed out a whole thing. Where have you been?
I didn't.
Maybe because you weren't sitting down. Maybe because I don't like you. I don't really know. No, just kidding. There you go. There's a copy.
Oh, thanks.
Okay. It just keeps going. Yeah. And there's new more. All right. See, mine bumped down there. Thank you. Okay. So an increasing exponential in the form y equals a b to the x. What does it tell us? What is the a of each of these?
Greater than 1. Or for b.
The b is greater than 1. What's my a? Yeah. Nope. Well, yes. Technically, yes. But that's not where I was going. Your a when it's in a b to the x. When it's just in the form a b to the x. A is your y-intercept, guys. A is your y-intercept. If there's no translations, correct? Okay. So I know that b would have to be greater than 0. Canyon's completely correct. And then what we do is we increase. Because if b is greater than 1, it's doubling or tripling. Remember we talked about things like that? Or it's like 1.045. It's increasing. By domain, I'm going to do these in interval notation. It's going to be negative infinity to positive infinity, and it would be really nice if I actually drew myself some asymptote on here. So there. The range, we know in interval notation, it's going to be greater than 0. So I have to do round bracket 0 because it's not equal to, and then round bracket on infinity because can't equal infinity. It's concept. And then your asymptote is a horizontal asymptote at y equals 0. Remember, HA is lovely, but it just says ha on a test. Kind of like it's laughing at you. That's all it's doing, if you write that. And the intercept is at 0 and?
0.
No. In this form, no. It's 0 and? A. Because you can't equal it. There's a dashed line on 0. Yeah. That would be not good to do it that way. Yes. Okay. An increasing logarithmic just looks like this. We're not going to talk about the equation at this very moment, but it looks like this. So you have your vertical asymptote like this, and it increases. It goes like this. Shabammy. We're going to deal with the log in a second. We're going to go to decreasing exponential first. So decreasing exponential, we've talked about y equals a b to the x. What happens to be about b if it's decreasing?
It's less than 1.
Yes. It's sandwiched between 1 and 0. It's less than 1 but greater than 0. So like 0 is as low as you can go. You can't decrease any further. 0 means you actually have nothing left. So that sucks. You can't have like negative nothing. You have nothing or more. Okay?
I mean, your bank account.
It's true. Your bank account could, but not your exponential function. So we have our asymptote along the x-axis, and then it decreases. We'll talk about the domain and range and that for these. I'm going to leave the logs for a second. So I'm going to go negative infinity to infinity, and this one would still be 0 to infinity. When's the only time that this isn't? 0 to infinity. If there's a reflection in the x-axis, it would cause it to be less than your asymptote. Correct? If there was a negative with the a, which we're not dealing with that right now. We're just doing a, b's to x's, all positive. I would have a horizontal asymptote at y equals 0. And once again, still 0 and a would be my y-intercept. A decreasing logarithmic. Lines are getting less straight as I go along. You have a vertical asymptote on the y-axis, and then it just decreases. It starts off larger and then decreases. We'll deal with the rest of that after. Okay, we're going to go to the next page. So this is where we actually get into logs and stuff. Yeah, that's all I heard.
Someone was telling me that they had to put logs in the equation.
It just happens.
No.
Okay, so a log function is the inverse of an exponential function. So for the function y equals 2 to the x, the inverse is x equals 2 to the y, which makes sense. I just plot my x's and y's, correct? This is great, and so is this. However, this can be written in a log form. So, this is something to note. B to the x equals n can be written as x equals log b to the n. These are converted back and forth. They mean the exact same thing. Now, if you pay attention, you won't mess these up. Paying really, really close attention? Do you agree? We're all paying attention. The base of our exponent is this bad boy. Correct? Do you see it? If you immediately take the base of your exponent and make it the base of your log, or the base of your log and make it the base of your exponent, you will not screw these up. You can also only have 3 items. So I have 1, 2, 3 items that I get to replace in 3 different spots. You see that? So let's go here. I go base of my exponent. It becomes the base of my log. That arrow's a little off. Do you see that I swap those? I can swap them right out. Then after that, what's with it with exponential is friends, and exponentials can't be friends in logs. What's with it in logs can't be friends in exponentials. So what's currently with it with an exponential? Just the x, right? Is the x still with it? No, what's with it now? The n. What's with it here? The n. So what's going to be with it here? The x. It's always the opposite. So if you place your bases first and remember that they don't stay together, they're really easy to convert. Okay? I've come up with 17 other methods. This is the easiest one for people to understand after 16 years of teaching. So let's try it out. AB equals C. I want to convert that to a log. So what's the first thing I do? I write log. And then I go look for the what?
Base.
The base. What is the base of my exponent? A. You see how that's the base of my exponent? It becomes the base of my log. And now I need to write something beside it. I have to write the C beside it because I can't write the B. They swap friends when they switch sides. So this is going to be C, and it's going to equal B. If you put your base first, life is good. If you don't, bad things happen. That's all I've decided. Okay? So, let's do log to exponential. What's the base of my log? 3. So that needs to be the base of an exponent. Well, currently a base of an exponent means it's a number and I got to give it an exponent. What do I got to give it?
A B.
A B, because what's with it right now? So can't stay with it. Swap friends. So now we're going to get B, and it's going to have to equal A. Okay, what's with this one? The base of my log is C. What's with it currently? E, so what needs to be with it as an exponent? D. And then it equals E. Crazy. So, I want to go back up to the equation we were talking about. We were talking about y equals 2 to the x, it's in, versus x equals 2 to the y. That's true. That's so true. Y equals 2 to the x is the original, and x equals 2 to the y is its inverse. That's true, because I just swapped my x's and y's. Do you agree? However, I can't type, how do I type that into a calculator? What do I need it in? What form? I need it in log because I need it in y equals. Correct? So this is not wrong. If they said, what's the inverse, and you gave that, you're not incorrect. If they say the inverse in y equals form, you're incorrect. So the first thing you have to do when you solve for an inverse, the very first step always to get an inverse equation is swap x's and y's, correct? Then it's to get y by itself. That's always the steps for inverses. Swap x and y, get y by itself. Well, I can't get y by itself like this. If I ever want the exponent to come down, the only way I can make that happen is changing it to a log. So I need this exponent to come down, correct? So what am I going to have to do? Convert it to a log. So, how do I do that? Well, I write the word log. That's the very first thing I do. Then I go look for the base. The base is 2. Now what do I have to write beside it? X, because what's with it currently? And I can't stay with it. Make sense? Not too hard. As long as you make the base be the base, your life will be good. Okay? Let's scroll down here. So we have 6 to the 3 equals 12. 216. 12. That's not even close. I flopped the 2 and a 1 and dropped the 6. It's a rough day. Okay, we have to change it to a log. How do we convert it to a log? The first thing we do is write log. And then we look for the, which is? And we write what beside it? 216, 261, people are flipping it with me, equals 3. Can I show you how to type that in? You ready?
Wait.
Because we're going to check it. I'll type around. Okay, so wait. Okay, so I just want to show you how you can type it in if you want to look at it. Because these are all numbers. We can actually see if it makes sense. Okay, how do I type in a log? Does anyone have an old calculator? TI-83. So you guys are not going to be able to follow along with TI-83s. Some TI-84s this won't work with. The TI-83s, your life's a little bit harder, but not like, sadly. It's just do it. Okay, so everyone's going to try this except TI-83s because it's just not going to happen. So some of the TI-84s, it won't happen as well. So let's just look for it. So this is my favorite button with the new calculators, and I apologize if you don't have the new ones because you won't have this option. So, how you get the button? Ready? You're going to press math. You're pressing math, and you're arrowing up because it's the path of least resistance. You can arrow down, it just takes you longer. So math, arrow up to log base. If you don't have this, sorry.
If you don't have the long one.
If you don't have this button, it's gonna, your life will be a little bit crappier.
Oh, we can't use this one?
No, that button's going to make your life harder.
I just tried to.
So did you go math and did you look for log base?
Yes.
If you have it, press enter. Boom, it gives you a base. Spot to put it in. So what was it? I don't even remember.
6
and 216.
6 and 216. Boom, got an answer. If you have the old calculators, you cannot use that button because you don't have it. So what you have to do,
So you go to
you're going to have to put it in with just the log button. So if you have the old calculators, pay attention. If you have the new ones, you can do it this way too. So it's good to practice. But what you have to do is you actually have to do this. Log base 2 of 6 of 216, you don't have the base button. So what you have to do every single time is you're going to have to do log 216 divided by log 6. It gets you the same answer.
Where's the log?
The log button is like 3 up from the on. I think it's 3 up. Haha! My brain did not fail me. It's 3 up. So it'll get you the same answer. So you can go log 216 divided by log 6. Same answer. Now, you have to remember that you have to divide by the base, not flip-flop them or you'll get the wrong answer and it'll be there. If you have a calculator, if you do this, the 6 has to be in the bottom. Okay, we're going to convert this bad boy. So we're going to write this as log what? Log base 3 of 81 equals 4. Now this is true, and you don't even need your calculators. Listen, listen, listen. This is what your calculator is doing. Paying attention? It's crazy. It's actually really cool once you learn what the heck it's doing rather than just typing it in. It miraculously gives you a solution.
Yeah.
So what it's actually doing every time you do the log buttons is it's doing this. It's saying 3 to what exponent is 81? 4. That's all it's doing.
Whoa.
Life changing. So if I gave you this, if I gave you log, oh thank goodness I'm recording. If I gave you log 2 of 8, what would the answer be?
4.
Three.
No.
It'd be 3. Because 2 to what exponent is 8? 3. If I gave you log base 2 of 16,
4. 4.
4.
4.
Four.
okay, paying attention. What if I gave you reverse? So I gave you log 16 2.
Oh, it'd be 1 over 4.
It'd be 1 over 4. It just makes it flip because it'd be the 4th root of 2. And 1/4 is 1/4 is the 4th root. It'd be the 4th root of 16 is 2. So what happens if it gives you ones that are not nice? Let's do this. Paying attention. Log base 2 of 5. I can get an approximate answer. I can't get accurate. My brain can do that. I can because I cheated and I did this last class. But if I hadn't, I couldn't get the real answer. So I go 2 to what power is 5? Well, I can get it sandwich numbers. What's closest to this? What's closest to 5? 4. So I can go 2 to the 2 is 4, but this is a little bit more. So it's going to be 2 point something. I think it's 2.31 and blah, 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 blah. Okay? So you go 2 to the closest one, which is 4, so it's 2 to the 2 is 4, so it's going to be 2 to the decimal something. Okay? So that's why you really need log buttons, is to help you out with those decimal ones. Ah, it's 2. Okay. All right, what about this one? What are we going to do? Log base 2 1/16 equals -4. Watch this. This is really cool. You guys can go 2 to the 6, 2 to the 4 is 16, or 16 to the quarter is 2. But what we could do actually, before we actually do this one, say I go log 2/16, right? And you guys say it's 4. What I could actually do is change 16 to be base 2. Watch this. So if I go log base 2, 16 is 2 to the 4, isn't it? So whenever these are the same number, your answer is the exponent. Whenever these are the same number, your answer is the exponent. Because 2 to what power is 2 to the 4? 4. It's because 2 to what power is 2 to the 4? 4. 2 to the 4 is 2 to the 4, right? So in this case, I could just do this as well. I could go log 2. What is 1 over 16? It's 2 to the what?
Negative.
Negative 4, isn't it? Because when I want to raise this to 16, I have to raise it to the negative 1. So 1 over 16 is 2 to the negative 4. Look, what's my answer? They match. Because you'd say 2 to what power is 2 to the negative 4? Well, it's negative 4. So when the base and the number beside are the same, your answer is the exponent. How do I convert this one? Log what?
Log 2x
Plus
plus
4.
4, a in brackets.
And then a goes in brackets equals negative 1. We're not solving that out. We're just converting. That's all we did for this question. We're going to flip over. What do you think we're going to do now?
Convert it back.
Convert it back. Convert from a log to an exponential.
45.
We need to know these very basic skills so that when we add some extra stuff to it, we can actually solve stuff. These are very basic to all the rest that we're going to learn. So here, if I have a log and I want to convert to an exponential, all I do is base of my log becomes the base of my exponent, correct? In order for this to be a base of an exponent, it needs a what? It needs an exponent, doesn't it? In order for this to be a base of an exponent, it needs an exponent. What's its exponent? 3. And it equals 125, which is a true statement. So you put your base down. In order for it to be a base, it needs an exponent, or it is not a base. It's just a number sitting on your page, floating there, looking pretty. That's about all it's doing. So what about this one? What's my base? 4. In order for it to be a base, though, it needs a exponent. What's its exponent going to be? Negative 2, because it can't keep what it has with it. Then that equals 1/16. Is that true? Yeah.
If we did it like 4 to the 2 equals 16, that would be wrong, right?
That would be wrong. What about this one? Okay, noting to self. When you have a square root, do we have to put the 2 for the index? No, and it's because square roots are the most often used root, correct? So a cube root, we have to put a 3. A fourth root, we have to put a 4. A fifth root, we have to put a 5, right? The only one that we don't have to put a number on is a square root, and it's because it's the most often used. The most often used log is log base 10. So whenever you see a log, they just don't put a base on it when it's a log base 10, because it's the most often used one, just like square roots have the most often used root, right? So what I always do immediately when I get a log without a base, I put a 10 there because you're probably going to need to use it. So that's the very first step I always do. So this one doesn't have a base, I put a base 10 down. And now I can convert it. What's the base of my log? 10. So that's going to be the base of my exponent. In order for this to be a base, I need an exponent. What's my exponent? 3, and it's going to equal 1,000. What about this one?
A to the power of x equals 2.
These ones you're going to give me your answer quickly, because you can. Log base 2 of 8, what's the answer?
3.
3, because 2 to the power of 3 is 8. We could also write this as log base 2, and then 8 is 2 to the 3, correct? So it would be 3. Instead of having log base 2 of 4, I could write it as log base 2, and then 4 is 2 to the 2. So what would my answer be? 2. It's always the exponent. This one is 2 to the 2 to the what if there's no exponent? 1. So what would the answer be? 1.
0.
Yeah, 2 to what exponent gets you a 1? 0. So whenever you have a 1 here, your answer is 0. And what they'll do often is not give you a 2, because you could type that in, correct? What they'll do is give you this. Log base A of 1. And you need to get an answer. And it's 0. Because you say A to what exponent is 1? 0. Say you were stuck. The base of a log can't be negative. That's something you need to know. So you could go log base 2 of 1, log base 3 of 1, log base 4 of 1, log base 5 of 1, log base 6 of 1. And after doing about 7 of them, you're going to realize the answer to all of them is 0. So if you're absolutely stuck with a variable, plug something into it a few times and see if it gives you the same thing all the time. Right? That can help you. You can plug stuff in. Now this one, what is 1/2? Yeah. So this is log base 2, 2 to the negative 1. So my answer would just be negative 1. And a quarter I can write as 2 to the negative 2. So my answer would just be negative 2. I like that you feel that way. I'm going to see if it stays there. Okay. We have example 5. Example 5. So, paying attention. If they want you to solve an exponential, do you see this? Do you see there's a variable in the exponent? Do you see that? The only way we know how to solve that currently is by common base. But then I told you that common base is not always going to work, correct? We agree? So, what could I do in this instance?
Swap X and 1.
Not swap x and 1. Yeah. Now I want to do algebraically.
How do you turn into a log?
Turn it into a log. If you ever want this exponent to come down, what did I tell you you can do? Convert it to a log. You can only convert it to a log, though, if there's one exponent. If there's two, you can't convert it to a log, just so you know. There's going to be another different way we have to do it. But so this, we can convert. When we want this exponent to pop down, when there's only one, we can convert it to a log. So I write log. What's my base? What goes beside it?
3.
And what does it equal?
X equals
And then you just get an answer. 1.6.
Yeah.
What about B? We're going to go log base 5 of equals x. And what does x equal? That makes sense. It has to be less than 1 because it's 5 to what power gives you 4. For C, log base 2. What goes beside it? 5. And the catch with this one is it equals x minus 3. So I have to do what first? Add 3. Yeah. So I get log base 2 of 5. Close the bracket. Add 3. This 3 does not join the 5. Don't make it join the 5. Don't let it join the 5. It will be back. And it equals x.
X equals 5.3.
Yep. Because this is 3.3 plus, or 2.3 plus 3. 5.3. We're going to go to D. What's the problem with D?
Log 4 to the 7 equals 2x plus.
Oh, I meant the second D. I have 2 Ds. That's hilarious. D2. Darkwing Duck. D2. What's the problem with D2? You did that correctly. That's good. But what's the problem with D2? There's a 5 sitting out there.
Oh, but it's 5.
Can the 5 join the 2? No, it's illegal. What could the 5 do, though? Divide over. And it only can because this 10 doesn't have an exponent, correct? If the 10 has an exponent, we cannot do it this way. There's a new way. We haven't learned it yet, but there will be. So we're going to get 2 to the 2x minus 1 equals 2. Do I even have to convert this one? You could do same base. So I don't even need to convert. I can go 2x minus 1 equals 1, 2x equals 2, x equals 1. And then with E, what do I have to do? Divide by 4. So I get 3 equals 3 to the x minus 2. This one I can also do by common base. So I can go 1 equals x minus 2, so x equals 3. Or, if I have 3 equals 3 to the x minus 2, I have 3 pieces. So I could go log base 3 of 3 equals x minus 2. And what's log base 3 of 3?
No, 2. What? 1.
It's just 1. So it's still x equals 3. Didn't change. I would always choose common base if given the option. Any day, any hour. So I'll give you the homework that you have to do up to this point. There's way more on there.
How would you do, would you just divide the end by,
2. Are you talking about that one?
Yeah.
Yep. So this would be log base 4 of 7
plus
equals 2x minus 1. Log base 4 of 7 plus 1 equals 2x. And then take your whole answer, divide by 2.
yeah, okay, that makes sense.
Okay. So there's right on the awesome. Page 380. There's going to be a few pages. Page 380, numbers 2 and 3. And 8. And then page 412. Number 2. This is the solving exponentials by converting to a log. That's number 2.